This section will set the stage for our journey into the past, introducing viewers to the concept of the deep history of the Earth. It will talk about how the formation of the Earth and early periods such as the Chaldean and Archean ions laid the foundation for life and the world as we know it today. Origin of the solar system. This journey begins about 4.5 billion years ago with the birth of the solar system. This section will delve into the widely accepted nebular hypothesis, explaining how a colossal cloud of gas and dust, known as the solar nebula, collapsed under gravity, leading to the formation of the Sun and the surrounding planets, including Earth. The Hadean Eon. Named after Hades, the Greek god of the underworld, the Hadean Eon represents Earth's earliest era, a hellish landscape devoid of life as we know it. This part of the article will explore the extreme conditions of this eon, marked by a molten surface, frequent volcanic eruptions, and a constant bombardment by meteorites. It will also discuss the significance of the late heavy bombardment period and its impact on the planet's development. Formation of the Moon. A pivotal event in Earth's early history was the giant impact hypothesis, where a Mars-sized body, often referred to as Theia, is believed to have collided with Earth. This section will explain how this cataclysmic event led to the formation of the Moon and its subsequent effects on Earth, including the stabilization of the planet's tilt and rotation, which played a crucial role in the development of life. Creation of Earth's oceans and atmosphere. As the Earth cooled, the outgassing from volcanic activity contributed to the formation of the atmosphere. This part will explore how the cooling of the planet's surface led to the condensation of water vapor, which eventually formed Earth's oceans. It will also touch on the theories regarding the origin of water on Earth, including the role of icy comets. Setting the stage for life. The conclusion of this section will focus on how these tumultuous early years of Earth set the stage for the next significant chapter in Earth's history. The emergence of life. It will highlight the transition to the more stable conditions of the Archean Eon, where the first signs of life appeared, marking the end of the Hadean Eon and the beginning of a new era. Archean Eon. Marking the start of the Archean Eon around 4 billion years ago, Earth began to cool, forming stable continents and oceans. This period witnessed the first signs of life, with the emergence of simple, single-celled organisms, known as prokaryotes. The section will explore how these early life forms likely relied on chemosynthesis, a process of obtaining energy by breaking down chemicals from Earth's crust, rather than photosynthesis. Appearance of stromatolites. One of the earliest and most significant forms of life were stromatolites. These layered, rock-like structures, formed by the growth of microbial mats, provide some of the oldest direct evidence of life on Earth. This part will discuss their significance in Earth's early biosphere and how they offer crucial insights into the early forms of life. Great Excisionation Event. A pivotal moment in Earth's history was the Great Excisionation Event, occurring around 2.4 billion years ago during the later part of the Archean Eon and into the Proterozoic Eon. This section will delve into how the activity of cyanobacteria, one of the first organisms to perform photosynthesis, began to release significant amounts of oxygen into the atmosphere, fundamentally changing Earth's environment and paving the way for more complex life forms. Proterozoic Eon and eukaryotes. This era saw the rise of eukaryotes, cells with a nucleus, which are believed to have formed through a process known as endosymbiosis. The section will explore this crucial step in the evolution of life, leading to more complex organisms, including multicellular life forms. Snowball Earth and its impact. The Proterozoic Eon also experienced dramatic climatic changes, including the Snowball Earth hypothesis, which posits that Earth was entirely or nearly entirely frozen over at least once. This part will discuss how these extreme ice ages may have spurred evolutionary innovations, leading to the diversification of multicellular organisms. Lead up to the Cambrian explosion. Concluding the section, the focus will shift to the conditions and evolutionary changes that set the stage for the Cambrian explosion, a remarkable period in Earth's history when most major animal phyla appeared in a relatively short geological time frame. Theory of continental drift. This section will begin by introducing Alfred Wegener's groundbreaking theory of continental drift, proposed in the early 20th century. It will describe how Wegener's observation of the jigsaw-like fit of continents, especially Africa and South America, led him to suggest that continents were once joined together and have since drifted apart. The initial skepticism and eventual acceptance of this theory will be discussed. Formation of Pangaea. The focus will then shift to the formation of Pangaea, the supercontinent that existed during the late Paleozoic and early Mesozoic eras. The article will describe how, through the process of plate tectonics, the Earth's continents slowly converged to form this massive landmass around 335 million years ago. Life on Pangaea. This part will delve into the impact of the formation of Pangaea on global climate, ecosystems, and evolutionary pathways. It will discuss how the interior regions of this vast continent were likely arid and inhospitable, leading to unique adaptations in flora and fauna. The effects on sea levels and oceanic circulation patterns and their implications for marine life will also be explored. Breakup of Pangaea. The breakup of Pangaea, beginning around 175 million years ago, was a pivotal moment in Earth's history. This section will examine the forces driving this breakup, such as mantle plumes and tectonic movements, and how the fragmentation led to the formation of the continents as we know them today. Impact on biodiversity and climate. The breakup of Pangaea had profound effects on global climate and biodiversity. This part will explore how the isolation of landmasses led to the diversification of species through allopatric speciation. It will also discuss the changes in ocean currents and atmospheric circulation patterns and how these changes influenced global climate. Legacy of Pangaea. Concluding this section, the legacy of Pangaea in shaping the Earth's geological features, climate, and biological diversity will be highlighted. The enduring influence of this supercontinent on the distribution of flora, fauna, and even the formation of fossil fuel deposits will be emphasized. Rise of the dinosaurs. This section will start by exploring the Triassic period, the dawn of the Mesozoic era, around 252 million years ago, following the Permian mass extinction. It will describe how this extinction event set the stage for the dominance of dinosaurs, discussing the early forms of dinosaurs that emerged during this period and their evolution into a diverse array of species. Jurassic period, a world of giants. The Jurassic period marked the middle of the Mesozoic era, a time when dinosaurs truly dominated the Earth. This part will focus on the iconic giants like Brachiosaurus and Stegosaurus and the evolutionary advancements that allowed dinosaurs to grow to such immense sizes. The flourishing of plant life and the evolution of the first birds will also be covered. Cretaceous period, the last chapter. In the Cretaceous period, the final period of the Mesozoic era, dinosaurs reached their peak in diversity. This section will explore the diverse habitats that dinosaurs occupied, from dense forests to open plains and coastal areas. It will also introduce some of the most famous dinosaurs from this period, such as Tyrannosaurus rex and Triceratops. Dinosaurs and their environment. Discuss how dinosaurs interacted with their environment, including their role as predators and herbivores, and how they may have shaped the ecosystems around them. This part will also delve into the latest research on dinosaur behavior, including social behavior and nesting practices. End of the dinosaurs, the mass extinction event. The section will culminate with the Cretaceous-Paleogene (KPG) extinction event about 66 million years ago, which led to the demise of the dinosaurs. It will discuss the prevailing theory of a massive asteroid impact, along with other contributing factors like volcanic activity and climate change, and how this event led to the end of the Mesozoic era and paved the way for the rise of mammals. Legacy of the dinosaurs. Concluding the section, the enduring legacy of the dinosaurs will be highlighted. It will touch on how the fossil record of dinosaurs provides invaluable insights into evolution, biodiversity, and the Earth's geological history. The cultural impact of dinosaurs as symbols of prehistoric life and subjects of scientific curiosity and popular fascination will also be discussed. Post-dinosaur world and the rise of mammals. Following the mass extinction at the end of the Cretaceous period, the world's ecosystems underwent dramatic changes. This section will explore how the extinction of dinosaurs created ecological niches that allowed mammals to diversify and flourish. The early part of the Cenozoic era, known as the Paleogene period, saw the rapid evolution of mammals in size, shape, and ecological diversity. Adaptive radiation of mammals. This part will delve into the concept of adaptive radiation, where mammals evolved to fill various ecological roles vacated by dinosaurs. It will cover the emergence of different mammalian groups, including marsupials, placental mammals, and the unique egg-laying monotremes. Evolution of primates. The article will then focus on the evolution of primates, which began in the tropical forests of the Paleocene. It will trace the lineage from early primates to the emergence of hominoids, ape-like ancestors, and discuss the significant adaptations that occurred during this period, such as increased brain size and the development of opposable thumbs. Human evolution. This section will explore the journey from early hominids to modern humans. It will discuss key fossil discoveries like Australopithecus, Homo habilis, and Homo erectus, and how these species contributed to the understanding of human evolution. The development of bipedalism, tool use, and language will be highlighted as critical milestones. The role of climate change in human evolution. Examine how shifting climates and environments played a crucial role in human evolution. The article will explore theories on how climatic fluctuations, such as ice ages, influenced migration patterns, adaptation, and the development of diverse human cultures. Spread of modern humans in the Anthropocene. The final part will cover the spread of Homo sapiens across the globe and the development of agriculture, which marked the beginning of a new geological epoch, the Anthropocene. It will discuss how human activity has become a dominant influence on climate and the environment, shaping the planet in profound ways. Conclude by reflecting on Earth's incredible journey through time. Emphasize the importance of understanding our planet's history to appreciate its current state and to anticipate future changes.